I prepared this today while I was at a unconference, so it's super prepared. But luckily, I have read the paper, so.
You have hours to spare.
I know. I think Andy's best preparing was literally writing the slides as he was walking onto the podium, so not quite that bad. Yeah, so framework for understanding unintended consequences of machine learning. It's 2 MIT researchers. Hopefully it's pretty intuitive, but I think it's got some really great, helpful, just mental world building concepts in it. So just to start with, they have 2 concepts of what kinds of harms might come out of a machine learning prediction, classification, predictive modeling kind of thing. And they are allocative harms and representational harms. Allocative just means I am giving something out and you may get less of it. This people represented in some sort of intersection of bias may get less than they fundamentally deserve, however you might define that, than if the world was perfect. So sometimes allocations can be for good things like getting a mortgage or getting a candy, and sometimes it can be for bad things like staying in jail, like the Compass recidivism algorithm. So you can keep in mind that allocative harms are not always just like you get the good thing, and there's a subset argument there, which is sometimes you can get something which can seem good but can be problematic. So particularly when you think about finance, it might be great for me that I get lots of credit on my credit card, but then it's terrible because I racked up 20K of debt. So depending who you are and how you handle something like money, for instance, it could actually be something which seems like a benefit, but could also cause problems. So yeah. And then representational harm, is what it says on the box. Are you well represented in that data set? Is your voice being heard? Are you having a say, essentially? So they came up with these figures that I thought were quite helpful. So they came up, just to give you a quick overview, these are the 6 kinds of bias they wanted to define. But the thing I think is really nice and unique in this paper is they basically help you frame it as like where it happens in the machine learning process. And I think that's actually quite a helpful way of teasing some of these things apart. One thing I will say is, as I've worked through examples of these types they've defined, I still find there's a little bit of overlap or a little bit of blurring. So I'd sort of like, the caveat is like, it's kind of not perfect as if you want to think of it as a perfectly linear buckets that you can define. It's not exactly that, but it's still quite helpful as a mental model. So just to like talk this diagram through really quickly, historical biases like, the world before we ever built a model. Representation is like how I'm selecting my population, what measurements and proxies I'm using, and then like the training stage. What have we got down here? And then we've got like differences between training and evaluation data, what I do at the aggregation phase, and then how I'm using it. So it's basically just a way of thinking about all the phases that happen in the machine learning training process and where these like problematic biases might come in. And it's worth like saying bias is not always bad. Like I'm biased towards enormous earrings. That doesn't cause a problem in the world. Like bias is just a preference essentially, but sometimes bias can be harmful when it means that some people are getting more than they deserve or less than they deserve. So yeah, I just want to talk these types of bias through. I might be a little bit less than 10 minutes, but that's okay probably. So historical, they define it as a misalignment between the world as it is or what we think it should be. It's essentially a normative statement. So like it's a normative statement is there should be just as many women as men building machine learning systems. Like I have a value set inherent in that statement. It obviously does not reflect the world the way it is. It's a normative statement saying this is the way I think the world should be. Does that make sense? Yeah, so like when we think about historical bias, like a good example to try and like keep it fresh in your mind is like when you go on Google and you search for CEO or doctor and it's like a lot of white dudes, like that's one of the sort of things that you can think of, like something where people sort of aren't demonstrating a representative of like the population actually represented there, or I mean, it's like all the kinds of structural and sort of inequalities. It's actually, there's so many things in this, and basically it's like intersectional feminist studies 101, but like basically this is the biggest one and the hardest one to intervene on, and it's also the one where we probably need more than just programmers in the room to talk about it. Representation bias is, yeah, like, it's the one that we all think about the most, probably, and like to talk to the most, because it's about sampling, and that's something we understand and we can like get our heads around. But what's important to recognize is that you can't sample your way out of a problem if that person wasn't ever represented in the data to begin with. So sampling is often something we think is like the nice way to fix bias in a machine learning project, but may not solve our problem depending on where the bias existed in the first place. So to make that real, like that might be, there's lots of ways of creating like a bias in the way I sample my population. So it could be who I even decide to ask in the first place. Out of everyone in the world that I potentially could be trying to observe, how did I select my sample population? Or what is my polling methodology? Have I picked a channel that is inherently exclusionary to some demographic? So like, if you call me on the phone to ask me questions, I will just never pick up. So you might find that people under certain ages are less well represented as a result of your polling methodology or your data collection methodology. Yeah, sorry, by the way, please shout out if you want me to talk more to any of these, or if you have questions, or if you have great examples, please shout out too. So I would love to hear you be like, oh, it's like that annoying thing that happened. Measurement bias, it's more around how we're defining our proxies and how we're thinking about what it is we're trying to observe, and like the sort of tension between the data that we can collect and what we're trying to infer from it. So an example I like to think of for this one, which I think is pretty evocative, is the Apple credit card thing that DHH was tweeting about. Does everyone know this example? Like Apple credit, like his wife got like 10 times less credit than he got. He was like, why was this a thing? Why did I, we have the same finances and she has better credit rating than I do, so why did I get a significantly higher credit offer? So if we think about proxies, almost certainly what they learned on was historical credit accepted. So you've applied for a credit card, you've gone through the process, and then you've taken some credit limit. And that's the proxy for credit worthiness. But what it doesn't take into account is how much you asked for and what you were offered. So a common sort of truism trope is that women are a little bit more financially conservative. So you could imagine that if you really wanted to understand credit worthiness, you would try and like interpret both what people asked for and what they accepted. And in fact, credit worthiness might be more like, did I ask for 10K and then accept 5K, as opposed to, did I like ask for 15K and then accept 50K? Because you might say that second person is much less credit worthy or much less fiscally responsible, but if they're only going on the one number of how much they were given, then you don't know any of that other detail. Does that make sense? Cool. Aggregation bias is basically the thing when we overgeneralize because we haven't got disaggregated data. There's a great book that gives us a lot of examples of this called Invisible Women by Caroline Credo Perez. Has anyone read that? Invisible Women? Should all go read it, especially because you're mostly dudes. But seriously, it's great, and it basically is just like a litany of ways that the world is designed for men at the exclusion of women. And it talks to what you might miss out on or not understand by not having that disaggregated information, like understanding how the subgroups can be different from each other. Cool, questions? Kind of got it? Oh, here's a good example of this one. There's been a lot of like cool medical apps going around that are like, take a photo of your skin and then it will tell you if you have a melanoma or not. And that's great if you have a light-skinned arm. And for everyone who has like medium to dark skin tones, it performs really poorly. And that's because on people with the darker the skin you have, the more differently melanoma and like skin abnormalities will appear. And in fact, like a lot of the characteristic melanoma things that they'll look for on white-toned or lighter tones like skin will actually just not ever appear on someone with dark skin. So basically you have a whole subgroup which has quite a different sort of like pathology for that particular issue, and it just hasn't been captured in the data, and it hasn't been like trained on as a separate classification, which it should have. Yeah, does that help? Yeah, a little better. Evaluation bias, this is like things like your benchmarks for quality, or if you have a change in like what you trained on and what you're testing on, or even if your production data changes wildly from what you were originally training on. So like the thing that you kind of thought was quality or accuracy, if there's like some big change between that and where you are in production, that's when these sorts of evaluation biases can come into play. So you probably all seen this paper by, I'm gonna say her name wrong, but Joy Bulamami. The lady who's like Algorithmic Oppression League, and she did all this study on facial recognition across different skin tones. And she basically showed that on some of the major commercial like facial recognition algorithms for women of color with darker skin, the accuracy was almost no better to chance, which is really bad. But the thing to think about there is if you had obviously that's a representation sampling problem because you don't have enough representation of those people in the data set, but also you should be evaluating for quality across different subdemographics. And clearly they had no quality assessment of those particular
Could you give some insight into like the difference in their work between like evaluation and aggregation?
In terms of Bulawami's work.
No, just the paper.
Sorry, say it again.
In terms of the authors of the paper.
Yeah.
Do you suspect like what would...
Oh, what is the difference between evaluation and aggregation? Aggregation is more about like overgeneralization, and evaluation can have other like as I said, like the test to train or train to production. Oh, sorry, I said that the wrong way around, but I'm overtired and it's your fault. So we stayed up late watching Picard last night because we are total nerds. So apologies, and also I've been at a conference all day, so apologies, guys. But yeah, my gut feeling is that it's both knowing what the differences are, so knowing whether your measures of quality are working well as your data changes, and also knowing whether your measures of quality are good in the first place or are sufficient, are telling you enough about the output of your model. Does that help a bit? Kind of?
Got one example that I feel like it almost applied to most of them. It's kind of a funny GIF or a funny picture that gets sent around like a meme where you got 5 people and the guy in the middle is a very dark-skinned guy, and he's got a white T-shirt with a face on it, and it's got square boxes around every face except his. So black guy's in the middle. There's a square box around his T-shirt, the face on his T-shirt, and he gets missed out from facial recognition.
Oh.
I feel like that kind of applies to the last 3.
Yeah, so like that's probably representation. It's almost certainly historical bias.
Yeah.
Yeah, I mean, as I said, like these are not perfect discrete categories. They're just a framework to help us like think about teasing these problems apart. And specifically, like I think we just have to get really careful not to say, oh, I can fix it with better sampling or with changing my data collection methodology, which I have heard people say quite a lot, and it bugs me. So I think we should, especially like keeping in mind that we have to grapple with like the nature of the world as it is, and if it is okay for us to propagate and amplify that. So that's essentially like, yeah, historical bias.
That's a big flaw in capture technology, why that doesn't work. You don't have dynamic range TV sets.
Yeah.
Capture photos.
Yeah.
You get the polygons off the face of the dark skinned person, the white skinned people properly exposed. It never worked. It's probably 20 years away from having a sensor to do that.
Yeah, or we need to add some other sensor on top of the type of light capture we're currently doing. I mean, yeah, like 100%, we have like literal physics problems to deal with here. And it's not about someone saying, oh, I just really want to be racist. But we still have to grapple with the outcome of that. It doesn't mean that we can just ignore that that exists.
Face on T-shirt is a detection problem rather than a classification. So,
Yeah.
if whatever you're doing inference or training, if you put it into label that person on T-shirt, that's a wrong label. If you do extra person and then the face.
Mm.
So,
True.
Yeah,
to
absolutely.
go from that point about the cheap answers not being able to pick up the polygons and that sort of stuff, I don't want to say that the reason why we decided that that level of quality of camera is good enough to bias in itself, because it picks up white faces fine.
Yeah.
So
Yeah, and it's funny because it has like a perfect analog historical like bias from, does anyone know like the history of Kodak film and how they couldn't like photograph dark-skinned faces forever? Yeah. Oh yeah, go read about it. It's wild. So this is like a terrible thing that we had this whole problem and then we're like, okay, new technology, same old problems. Anyway, to keep going,
What's
just,
the,
yo,
I'm just thinking, where would you say like specification of the system? Say someone approached you with a problem.
Yeah.
Military death robots, or baby
Yeah.
care robots, or whatever, right?
baby shredders?
baby care, military, take your pick. But the specifications of the system can be problematic. Where would you say that fits into this whole thing out of all these categories you mentioned?
Sorry, baby care or military?
Well, I'm just saying you have two choices. Let's just say you pick the baby care
Yeah.
robot,
Yeah,
and has to do all its detection capabilities.
yeah.
And someone writes up a list of specifications of how this thing,
Mhm.
like the outcome of how it should be operated. These are the confidence levels, etc.
Mm-mm.
Where would you say that comes into these biases at the end of the day? Because the specifications can have their own problems. Like here's a specification, and you
Yeah.
forgot about thermal sensitivity, and the whole thing
Yeah.
explodes in a melting lava.
Absolutely. I'm going to answer your question with an example.
That's great.
So I was reading about a team that was working on some like abstraction on top of like a default facial recognition library that they were using as a third-party service. And then they had some like client come in that was like, oh, you have to have a equivalent accuracy or I might have been recalled, but anyway, like some measure of quality had to be equivalent across like these sub-demographics. So I think it was like darker skinned people of color, Asian people, white, Caucasian people, and a couple others. And they basically, because of the physics problem we talked to earlier and like the lack of good data and insufficient resolution, they couldn't fix it technically, so they just added noise at the top end. So that's a great example of how like not to fix problems because you don't have like sufficient buy-in in the team to the problem you're trying to solve, or understanding like how you're trying to assess the trade-offs that you're making in a team or in a product. But I mean, I think that to write a specification, you should be probably sitting with one of these sort of maps and saying like, do any of these apply? And if so, how problematic are they? And how, what might we do to mitigate them? We do have a lot of libraries that are like already working on things like interpretability and like attention and those sorts of, I saw a paper the other day on adversarial explanations, which, does anyone listen to Data Skeptic? It's a great podcast, listen. And they had this thing on adversarial explanations, which is like another version of like model explanation. And it sounded really fascinating, and it's sort of, one more tool in the toolkit to try and like think about how to make these things more robust and more interpretable in production. But basically, I don't have a perfect answer for you, but I think like we have to at least start asking these questions at the sort of definition phase, as opposed to like, oh wait, that went live, is that okay? Who knows? Okay, deployment bias is how is this thing used in production? So if we think about the distance between how we think our tools are going to be used and then what actually happens in real world, and I'm sure we've all had this experience as like, software engineers and making products, there's often a big gap between what we think is going to happen and then what actually happens. And the same is true with these sorts of classifications or predictions. We might think it's going to be what's called a decision aid, like something that will help someone make a decision, but it becomes essentially the proxy decision. That's very much what happened with Compass, the recidivism algorithm. Like people were like, this is supposed to only support the panel deciding whether or not to keep these people in jail or release them. But essentially they looked at it first and they were like, oh, we think it's cool. And I think like you could think of another way to deploy a score like that, and it might be maybe you have to sit down, interview the person, have your discussion as the panel, make a choice, and then see the score. And at that stage, you're not primed by what you saw on the score, and you don't necessarily Like, and if you disagree with it, it might make you question the score as opposed to just like accept it blindly. So thinking about how it's actually used, how much faith people put in it, how much we're exposing the level of uncertainty we have about the outcome of that classification, like those sorts of things are deployment bias.
I can give a simple practical example.
Great.
We've got work safety system where, and we did presentation 2 weeks ago where a person has to wear a personal protective gear,
Mhm.
depending on where the person is located. The person goes to area where they have to wear it. It's for construction. It comes from about 1,000 different elements. Some start the screening. They say, okay, if how we're going to treat this data, are these people going to punish, or we're going to use this like metrics where we're watching safety. So I suggested, can use smart systems make a dot line towards this person. And you can see, depending on the approach of the person who's the manager, that fairly simple AI system may fail or may achieve a great result.
It could be punitive and it could be assistive, and it really depends on how you use it. I was thinking about those drones following people around in China being like, go inside, auntie. Why are you outside? Why haven't you got your mask on? Has anyone seen that footage? That went around a few weeks ago. And like, I don't know. I mean, I understand what they're trying to do, but it's still really freaking creepy. Yeah, sorry. Oh shit, I've taken so long. Sorry. This is their formalism. It's not very exciting. It's just important to remember that they're saying like, start from all the world and then select your population, start from your population and work out your sampling set. It's just trying to show you like how these types of bias might flow through. I don't remember what all these variables mean, but you can go read the paper if you care. It's actually like not that exciting. And FYI, I'm working on a worksheet to try and help us like unpick these for ourselves for the process of scoping and deployment. Okay, let's keep going.